everyone, welcome to my YouTube channel Study with Soumya. Make sure to subscribe this channel if you haven't subscribed till now, or if you are new to this channel then welcome to the channel, and make sure to subscribe and turn on the bell icon so that you don't miss any update or opportunity from the channel itself. So make sure to subscribe. Also do join us at our Telegram channel. The link for the Telegram channel is given in the description itself. So make sure to join and be a part of our Telegram family. Well, as if your Capgemini exam is approaching, so that's why in this video we'll be solving Capgemini pseudocodes. So these pseudocodes has been asked in the Capgemini itself. So this video is going to be very helpful for you. So make sure to watch the complete video, and what else you can do to support us, just share the video with your friends as well who are having Capgemini exam in upcoming days. So without any further discussion, let's start with the first question. So here's our first question. The question says that consider an undirected graph with 4 vertices. The adjacency matrix of the graph is shown below. You have to determine the number of self loops in the undirected graph G, right? So a graph is there. Also they have mentioned that it is undirected graph. So well, we have two graphs like directed and undirected. In directed graph there is something like direction that you can move from here to here, but you cannot come from here to here because there is only one direction. Whereas in case of undirected graph, there is no direction. You can go here to here and then here to here. Everything is possible, right? So they are saying that we have been given an undirected graph G with 4 vertices. And so let's make a graph. So let's suppose we are having 4 vertices. Let's suppose they are 1, 2, 3, 4, right? So this is what we are having. 1, 2, 3, 4. 1, 2, 3, 4. And you must be knowing that we can represent the graph using adjacency matrix or adjacency list. Here adjacency matrix is given to us and we have to determine the number of self loops present in the graph. What are self loops? When, for example, we are having a vertices like this, if an edge is coming from this graph and it is going back to this graph itself, this is what? A loop, right? This is what? A loop. Okay, so this is the adjacency matrix given to us. Let's draw the graph. So 1 to 1, you can see there is a 1. So when the value is 1, it means that there exists an edge, right? So 1 to 1, it means edge is coming out of 1 and going back to the 1 itself. Next we have 1 to 2. So 1 to 2, this is 0. It means there is no edge. 1 to 3, it is 1. So let's make an edge 1 to 3. 1 to 4, there is an edge. So let's make 2 to 1, that is 0. So there is no edge. 2 to 2, 0. 2 to 3, there is an edge, you can see. So let's make 2 to 4, there is an edge. So let's make. So what is basically this 1 and 0 showing? 1 is showing that yes, there exists an edge between the vertices, and 0 is showing that there is no edge between the vertices. 3 to 1, 3 to 1, we are having 1. So that means there is an edge. So we have already made this. 3 to 2, there is an edge, that's done. 3 to 3, you can see there is 1, it means there is a loop. So let's make a loop. 3 to 4, that is 0. Now 4 to 1, there is an edge, fine. 4 to 2, there is an edge, fine. 4 to 3, 4 to 4, that is 0. Now they are asking number of self loops. So how many self loops are there? 1, 2. So how many self loops are there? 2 loops are there. So we have to mark option D is the correct answer. Right, I hope you understood the question, and in case of any doubt, make sure to comment and I'll be replying you the answer. Right, so let's see the next question now. So here the next question says that identify the effects of using stack in recursion. So the first is that it is comparatively slower than iteration. So yes, recursion, always remember that recursion is slower than iteration. That's why for simple problem, instead of going with the recursive solution, we always prefer iterative solution, because recursive is kind of slower, because what is involved here, you are calling a function and then returning back the flow. So that's why it is slower when compared to the iterative solution. It uses more memory than iteration. Yes, that's also true for recursion. What data structure we do use, that is a stack. So it uses more memory than iteration, that is also true. So both the statements given are true. So what will be the correct answer? That both 1 and 2 are the correct statements given, right? Let's see the next question now. Next question says that while inserting the elements 71, 65, 84, 69, 67, 83 in an empty binary search tree in the sequence shown, the element in the lowest level is. Before proceeding further in the question, first of all, you should know that what is binary search tree. So for example, this is our binary search tree. So what is the condition? That parent node, let's suppose the parent node is 12. So the left child should be smaller than that of the parent child, so we can have here 10. Also the right child should be greater than that of the parent node, so we can have there 15, right? So this is satisfying the condition of binary search tree. So according to this particular condition, that left child should be smaller, right child should be greater than that of the parent node, we have to insert these nodes. So what we are doing, what they have given, that binary search tree, initially that is an empty binary search tree, so one by one we have to insert these elements and we have to build a BST, and then we have to tell the element which is at the lowest level. So let's start with the first element, so that is 71. Then next we are inserting 65, so 65 is less than that of 71, so it will be in the left side. Next we have 84, so 84 is greater than that of 71, so that will be on the right side. Next we have 69, 69, we have to place this one. Well, 69 can't be placed here because it is less than that of 71, but 69 is greater than that of 65, so that will be the right child of 65. So here's our 69. Next we have 67. So 67, where we have to place this? 67 is also greater than that of 65, but it is less than that of 69, so 67 is going to be the left child of 69 node. Next we have 83. So 83 is greater than that of 71, so but it is less than that of 84, so that will be the left child of 84. So this is our 83. Now they're asking the element in the lowest level, so which is the element? 67, right? So what will be the correct answer? 67 will be the correct answer. Here's our next question, that what will be the output of the following pseudocode. So here we are having three integer a, b, c, and we are setting b equal to 1 and c equal to 1. Now simply we are running a loop where a equal to 1 up to 3, right? So a less than equal to 3, so that is the condition we are running a loop. Now what we are doing, inside the loop we are changing the value. So what is this? What is this operator known as? And what is this operator known as? So that is right shift, and that is what? Left shift. Now how you can remember, sometimes there is a sort of confusion among the students, so just have a look on this arrow signs. आप सिर्फ ये arrow sign को देखो, ये arrow sign कहाँ पर है? Right side में, so you can remember that it is right shift, and यहाँ का arrow किधर की तरफ है? Left की तरफ, so that is left shift. Now what is the formula basically for right shift? For example, we are having a right shift by k. So what is the formula? The formula is that we use is a divided by 2 raised to k, and similarly if we are having a left shift by k, so what is the formula? A multiplied by 2 raised to k. So these are the two formulas, that is for right shift and that is for left shift. We'll be using the same formula here. So you can see there is the loop, and inside the loop we are doing the b, we are doing b equal to b right shift by 1. So what is the value of b? That is 1. So 1 right shift by 1. So let's keep this value in the formula. What is the formula? 1 divided by a value is what? 1. 1 divided by 2 raised to k. K value is what? 1. So if you will do 1 divided by 2, that will give you something in point. But as if b is of integer type, so we'll be putting 0 to this. So b has been updated to 0 now. Next statement that we are having in the loop itself is c equal to c right shift by b. The formula, okay, first of all the value of c is 1, the value of b modified value, that is 0, so 1 left shift by 0. Now what is the formula for left shift? That is a into 2 raised to k. It means 1 into 2 raised to 0, so that will be 1 itself, right? So now the value of a will be updated, that is going to be 2, right? First it was 1, now it is going to be 2. 2 less than equal to 3, condition is true. Again we'll be doing b equal to b right shift by 1. What is the value of b? It is 0, right? So 0 right shift by 1. So that is going to give us 2 raised to k. What is the value of k here? 1. So again you will be getting 0 itself, right? What you will be getting? You will be getting 0 itself. And as if b is 0, so again you will be doing the same thing, because c is what? 1. So 1 left shift by 0, then again you will be getting 1. So now again the a value will be updated to 3. 3 less than equal to 3, condition is still true. Now again if you will do the same operation, right, that b right shift by 1, so you will be getting b as 0, and c left shift by b, so again you will be getting 1, right? And now again the a value will be updated, it is going to be 4 now. 4 less than equal to 3, condition is false, so we will come out of the loop. And after coming out of the loop, we are doing b plus c. What is the value of b? 0. What is the value of c? 1. 0 plus 1 is going to give us 1, so that will be the correct answer. The correct answer will be 1. Let's have a look on this question. So basically what we are doing here, we are using XOR. So what XOR does, XOR is an operator. It is a logical operator basically, and it always results in 1, or you can say true. It always results in true when both the operands are different, right? And if in the case both the operands are similar, so we will be getting 0 or false as the output. So here we are having two integer values a and b both are set to 1. Now we are doing a XOR 1. What is the value of a? 1. 1 XOR 1, you can see both the operands are similar, so that will lead to 0 itself as the output. Now we are using this bitwise AND. Bitwise AND will result into 1 only if in the case both the operands are 1. So only one bitwise and 1 is going to give us 1. Otherwise, we'll be getting 0 as the output. So if you're having 1 bitwise and 0, so that will be 0. 0 bitwise and 1, that will be 0. 0 bitwise and 0, that will be 0. Right? So here you can see one value is 0 and another one is 1. So this whole expression will result into 0. Right? On the other side, we have this b XOR 1. So what is the value of b? 1. 1 XOR 1, that will give us 0, and 0 bitwise and 1, that will give us 0 itself. So 0 plus 0 is equal to 0, and now we are printing a plus b. So what is the value of a? You can see here we got the value of a as 0. This value that we got from this expression, that has been set to a itself. So a value is 0 and b value is what? 1, because we haven't done any modification in b value. So 0 plus 1, that will give us to 1 itself. So option A will be the correct answer. That is 1 will be the correct answer. Right. Let's see the next question now. So here's the next question. What we are doing basically. So we are having two variables, first and second. First has been set to 12 and second has been set to 20. Now you can see this is the operation of swapping. You all must be knowing that. Let me show you the same as well. That what we are doing, first equal to first plus second. So 12 plus 20, that is going to give you 32. That is going to give you 32. And next in second, what we are having, first minus second. So what is the value of first? 32. What is the value of second? 20. 32 minus 20, that will give us 12. Right? And next, what again we are doing, first equal to first minus second. So what is the value of first? 32. 32 minus 12, that will give us 20. So you can see the value of first and second has been swapped now. And then on the next line, we are just doubling the value of second. So that is, we are making it 24. So from the given options, you have to select that what is basically happening in this code. So the first option is it will swap the values of first and second. Yes, that is what happening. And double the second value. Yes. So after swapping the value, we are just doubling the value of second variable. So option A itself will be the correct answer. Let's see the next question now. So here's the next question. We are having two integer I and j, and we are setting I equal to 0, j equal to 0. And here we are running a loop basically. So what we are doing, first of all, we are incrementing the value of I, right? So initially I was 0. Now we are incrementing it. So now it has become 1. Now here in this part, so this can be kind of confusing for you. What we are doing, if j equal to j minus 1, right, less than I equal to I plus 1. So this is what we are having here. So j minus 1, what is the value of j? 9. 9 minus 1 means 8. So we are first reducing the value of j by 1, and then we are then we are setting this value back to the j itself. So 9 minus 1 is 8, and we are setting this value 8 back to the j itself. So j value has been become 8 now. So 8 less than here, what is the value of I? 1. And here we are incrementing this by 1 again. So 1 plus 1 will become 2, and I is now 2. 8 less than 2, the condition is true or not? No, right? So nothing will happen. And here we'll be checking while I less than 5. So what is the value of I? 2. 2 less than 5? Yes, condition is true. So we will move further in the loop itself. Now again we are updating the value of I, and we are making it, incrementing it by 1. So although it has become 2 before as well, so now it is going to be 3. You can see here it was 2. So now if we are incrementing, so that is going to be 3. So again we are checking the condition j equal to j minus 1. So j value was 8. Now it is going to be 7. 7 less than I equal to I plus 3, I plus 1, sorry. I value is what? 3. And again we are adding 1 to it, it means that is 4. So 7 less than 4, condition is true? No, right? So that is j value and that is I value. Fine. So nothing will happen. Again we'll be checking while I less than 5. What is the value of I? 4. 4 less than 5, condition is still true. So we will move in the do part itself. Now we are updating the value of I is I plus 1. So I is going to be 5 now. Now again we are checking this if condition, j equal to j minus 1. So j value will become 6 now. 6 less than I equal to I plus 1. So what is the value of I? 5. And now after incrementing, that is going to be 6. 6 less than 6. Is this condition true? No, right? So what we'll be doing? We'll be jumping out of the loop, because 6 less than 6, this condition is false. Now after coming out of the loop, what we have to do? We have to simply print the value of I and j. So you can see I and j both are equal, that is both are 6. So option A will be the correct answer for this particular question. Let's see the next question now. So here's the next question, that which of the following is the correct adjacency matrix for the given graph. So I have not included the matrix, but I will tell you that how you can make the adjacency matrix and you can determine the correct answer. So this is the graph given to us. So how many vertices does it have? 1, 2, 3, 4, 5. 5 vertices, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So how do we make this adjacency matrix? So if there is an edge between the two vertices, we have to mark it as 1, otherwise we have to mark it as 0. So first of all, 1 to 1, you can see if there is 1 to 1 will happen only if there is loop. So there is no loops, we have to make it 0. 1 to 2, there is no edge, so make it as 0. 1 to 3, is there any edge? No, there is no edge, so make it as 0. 1 to 4, yes, there is an edge, so make it as 1. 1 to 5, yes, there is an edge, so make it as 1. 2 to 1, there is no edge, so make it as 0. 2 to 2, there is no loop, so that will be 0. 2 to 3, there is no edge, right, so make it as 0. 2 to 4, yes, there is an edge. 2 to 5, there is an edge. Next we have, is there any edge from 3 to 1? No, so make it as 0. Is there any edge from 3 to 2? No, so make it as 0. 3 to 3, there's no loop, so that will be 0. 3 to 4, yes, so make it as 1. 3 to 5, so make it as 1. Also, it's not needed that you have to make the complete adjacency matrix. Just you can compare, like you'll be able to find out a matrix that is the only possible matrix that is meeting up to this sequence only. So directly mark the answer. It's not like you always have to make the complete matrix. And even if just by making up to here you are finding two matrices that is matching the sequence, in that case you have to make the complete. So let's complete this one. 4 to 1, you can see there's an 4 to 1, there's an edge, so that will be 1. 4 to 2 also there is an edge, so make it as 1. 4 to 3, there is an edge, so make it as 1. 4 to 5, there is no edge, so make it as 0. And 4 to 4, there is no loop, so make it as 0. 5 to 1, there is an edge, so make it as 1. 5 to 2, there is an edge, so make it as 1. 5 to 3, there is an edge, so make it as 1. 5 to 4, 5 to 4, there is no edge, so make it as 0. 5 to 5 is also 0. So that is the adjacency matrix for the given graph, right? I hope you understood that how to make the adjacency matrix. Let's see the next question now. So this is the next question, that what will be the output of following pseudocode for a equal to 6? So here do we have, basically here we have a function and a value given to us is 6, right? So first of all, what we are checking, that if a equals 0, so a is 6, that is not 0, so this won't be true. Otherwise, what we have to return? A minus 1. So we are calling the same function itself. So 6 value will be reduced to 5 now, and we are calling the same function. Again, a equals 0, so 5 is not equal 0. Again, what we are doing? We are calling the same function by reducing the value of a by 1, so that will be 4. 4 is also not 0, so again we'll be calling the same function by taking the value 3. 3 is also not equal 0, so again we'll be calling the same function taking the value as 2. Again taking the value as 1, again taking the value as 0. So if a equals 0, so now that condition is true, and what we are doing, we are returning a plus 9. So what is the value of a? 0 plus 9, so that will be 9 itself. So what will be the correct answer? Option D will be the correct answer. So is the next question that heap is more efficient for implementing priority queue than a linked list or an array, as it supports the following operations in big O login. So you have to determine that which of these operations are done in big O login. Insert operation, extract max, decrease key. So extract max operation is done in big O one time, so that won't be included in the answer because they are saying operations in big O login only. So insert is done in big O login time, and decrease key is done in big O login time, right? So what will be the correct answer? Option 1 and option 3. So only 1 and 3, right? So that will be the correct answer. Let's see the next question now. Question that if the speed of packets sent by a server is faster than the speed of receiver, then which of the following would be the most suitable for synchronization? So for this, the correct answer will be Q. Now why? Because packets come, when packet will come, so you have to serve them in FIFO order, that is first in first out, right? So जो first आएगा उसका पहले service होगा. So that is the case. And which data structure will help you in maintaining this concept? Q, right? So Q will be the correct answer for this particular question. So this is it for this video. I hope you have liked the video. Then make sure to hit the like button and do share this video with your friends as well. Thank you for watching this video. Don't forget to subscribe the channel. Thank you guys. Keep preparing. Be safe. All the best for your exam. Bye bye.